Hey everyone, welcome back to Ask a Chemist. Today we're going to solve a few problems on conversion factors. Let's get started. So our first problem asks us to determine the number of millimeters in 1800 meters. How do we approach this problem? Well, we need to know our variables. We know that we have a value of 1800 meters, but we don't know the number of millimeters. So we're trying to go from 1800 millimeters to a certain number of millimeters. How do we do this? Well, first we need to determine our conversion factor. Our conversion factor is 1000 millimeters is equal to 1 meter. Now we can set up our dimensional analysis table and then we can solve our problem. So to set up our table, we want to start with the value that we know that we have. So we know that we've got 1800 meters and we're trying to go to millimeters. We put meters on the bottom so that this will cancel out. And looking at our conversion factor, we know that there are 1000 millimeters in 1 meters. We have the same units on the top as we do on the bottom, so that cancels, leaving us with our desired units of millimeters. And we get a total answer of 1.8 million. If we want to put this in scientific notation, it would just be 1.8 times 10 to the 6th power millimeters. Let's do another one. Determine the number of millimeters in 15.9 seconds. So our variables are that we have a value of 15.9 centimeters, but we don't know the number of millimeters. So our conversion factor, looking at the table, will be 10 millimeters to 1 centimeters. So to set up our table, once again, we start with the value that we know that we have, which is 15.9 centimeters. And we're going from centimeters to millimeters. We want centimeters on the bottom. And then we just put in the values for the conversion factor. There's 10 millimeters in 1 centimeter. These will cancel because they're the same unit on the top and on the bottom, leaving us with 159 millimeters. Or you could say 1.6 times 10 to the 2nd millimeters. Okay, let's do one more. How many seconds are in 3.6 years? So we have 3.6 years. We don't know the number of seconds. Now, the conversion factor is not found on this table. This table consists of common conversion factors that you will use throughout high school chemistry all the way up until your last chemistry course. However, going from years to seconds is something that's not commonly done. So we can figure this out in the process of setting up the dimensional analysis table. So if we want to start off, we want to work backwards. We want to go from seconds to years. We know that we can figure out the number of seconds in a minute. We can figure out the number of minutes in an hour. We can figure out the number of hours in a day. And finally, we can figure out the number of days in a year. So we're starting off with 3.6 years. In 1 year, there's 365 days. And in 1 day, there's 24 hours. In 1 hour, there's 60 minutes. And in 1 minute, there are 60 seconds. So all of these values all these units that we don't want need to cancel to leave us with our desired units of seconds. And so if we multiply all of these across, we end up with a final value of 113,529,600 seconds. Or we could put this in scientific notation and say 1.1 times 10 to the 8 seconds. So in today's video, we worked 3 practice problems that covered the concepts of conversion factors and dimensional analysis. I hope that you found this information to be helpful. If you have any questions or comments, leave them down below or send them to Amakemist. Don't forget to subscribe, follow, and share this video, and I'll see you guys next time. Have a good one.